Welcome to AWS Mastery Labs, turning AWS chaos into clarity with bite-sized tutorials, hands-on labs, and exam-smashing tips. In this video, we'll explore how AWS Data Migration Service, commonly known as AWS DMS, can help you migrate your databases quickly, securely, and with minimal downtime. Whether you're moving data from on-premises to the cloud, between AWS regions, or transitioning from one database engine to another, AWS DMS is a powerful, fully managed tool that simplifies the process. We'll walk through the key concepts, supported source and target systems, and how DMS fits into modern cloud data architectures. Let's get started. When organizations consider moving their data to the cloud or modernizing their database platforms, they often run into a series of complex and interconnected challenges. One of the biggest hurdles is handling heterogeneous migrations. Transferring data between different database engines, like moving from Oracle to Amazon Aurora or PostgreSQL. These systems have different data types, indexing methods, and built-in functions, which means a simple lift and shift won't work. Then there's the issue of downtime. For mission-critical applications, even a few minutes of disruption can result in revenue loss or customer dissatisfaction. Minimizing or eliminating downtime requires careful planning and often real-time data replication using change data capture. Data consistency is another major concern. How do you ensure that every transaction, every record, and every update has made it to the target system without corruption or loss? Validating data across platforms at scale is non-trivial and needs rigorous checks. You'll also face schema compatibility issues, constraints, stored procedures, and even simple differences in date formats can break the target system unless they're handled properly. Performance bottlenecks are common, especially with petabyte-scale migrations. If the migration isn't optimized for parallelism and throughput, it can slow down your source systems or take unacceptably long to complete. Of course, security and compliance can't be an afterthought. Sensitive data needs to be encrypted during transit and at rest, and must comply with regulations like HIPAA, GDPR, or SOC 2. There's also the need for operational visibility. Without real-time insights into the migration process, like throughput, latency, and errors, it's difficult to respond proactively to issues. These challenges are why a purpose-built, fully managed service like AWS Data Migration Service becomes essential. It helps abstract much of this complexity and lets you focus on outcomes instead of operational hurdles. AWS Data Migration Service, or DMS, is a fully managed tool designed to simplify the complex process of moving data from one database to another, whether you're lifting and shifting to the cloud or replatforming to a new database engine. One of its biggest strengths is that it supports both homogeneous migrations, like moving from MySQL to MySQL, and heterogeneous migrations such as Oracle to PostgreSQL. This makes DMS a versatile choice for a wide range of migration scenarios. What really sets DMS apart is its ability to perform live migrations using change data capture, or CDC. CDC enables DMS to continuously capture and replicate changes made to the source database while the migration is in progress. This means you can keep your source systems fully operational, significantly reducing downtime during the transition. DMS supports a broad set of source and target endpoints, including commercial and open source databases such as Oracle, SQL Server, MySQL, PostgreSQL, Amazon Aurora, and even NoSQL databases like MongoDB. You can also migrate data to analytical systems like Amazon Redshift or to Amazon S3 for use in data lakes and archival storage. This flexibility makes it an ideal tool not just for lift and shift migrations, but also for hybrid data architectures. Under the hood, the core migration logic is handled by replication tasks running on DMS replication instances. These tasks operate independently of your application infrastructure, allowing you to define, monitor, and control the migration workflow with precision. Another powerful feature is DMS's ability to perform lightweight data transformations. You can filter data, rename tables and columns, and even convert data types on the fly, all without writing custom ETL scripts. All these capabilities make DMS a powerful, flexible, and production-grade solution for organizations looking to move their data to the cloud without rewriting their entire tech stack. AWS Data Migration Service offers a rich set of features that go beyond just moving data from point A to point B. One of its most powerful capabilities is automatic failover and high availability. By deploying replication instances in a multi-AZ configuration, DMS ensures that if one availability zone goes down, another picks up the workload seamlessly, helping maintain uptime and data continuity. Another benefit is how lightweight the service is on source systems. Instead of running resource-heavy queries, DMS reads directly from database logs, which minimizes impact on live production environments. This is especially important for businesses that can't afford performance hits during migration. To ensure data integrity, DMS includes built-in validation capabilities. After data is moved, it can compare records between the source and target to make sure everything matches, giving you the confidence that your data landed correctly and completely. For large-scale migrations, parallel load operations can be a game changer. DMS can divide tables into segments and load them in parallel, significantly accelerating the initial data transfer and shortening migration windows. It's also worth noting that DMS isn't just a one-time tool. It supports ongoing replication, making it ideal for hybrid or phased migration strategies where you need to keep systems in sync over time before cutting over. From a network standpoint, DMS is highly flexible. It works across a wide variety of configurations, whether you're using a VPN, AWS Direct Connect, or public internet, and can integrate seamlessly into complex VPC topologies. Lastly, when targeting Amazon S3 as a destination, DMS supports structured formats like JSON and Avro. This makes it easy to push data into a lakehouse architecture or use it directly in analytics tools like Athena, Redshift Spectrum, or EMR. In this illustration, we see how AWS Database Migration Service enables a secure and efficient flow of data from a source database to a target database hosted in the AWS cloud. The process begins on the left side with the source database, which could be on-premises, in a self-managed cloud environment, or hosted elsewhere. This database connects to a secure source endpoint configured within DMS. This endpoint handles authentication, connection security, and ensures that data is read safely and efficiently. From there, the data flows into the DMS replication instance. This instance acts as the engine of your migration. It's where migration tasks are created and executed, and it plays a critical role in orchestrating the entire migration process. These tasks typically start with a full load, where existing data is bulk transferred from source to target. But they can also include ongoing replication using CDC, which keeps the source and target in sync by capturing changes in near real time, essential for minimizing downtime during cutover. Once processed, the data flows from the replication instance through a secure target endpoint, which handles the right connection to your target database instance, typically a managed AWS service like Amazon RDS, Aurora, or Redshift. Throughout the entire pipeline, Amazon CloudWatch logs play a vital role by continuously collecting and presenting logs and metrics. These give you deep visibility into the migration process, including task health, replication lag, errors, and performance bottlenecks, ensuring a high degree of reliability, traceability, and confidence at every stage of your migration. This flow highlights the core value of DMS, a fully managed, secure, and resilient service that simplifies database migrations at scale without disrupting your operational systems. AWS Data Migration Service supports a wide variety of data sources and targets, making it a versatile solution for diverse migration scenarios. To better understand its capabilities, let's break down the supported endpoints into four key categories: relational, NoSQL, analytics, and data warehouse. Starting with relational databases, DMS offers broad support for both commercial and open source engines. You can migrate from traditional databases like Oracle, Microsoft SQL Server, and IBM DB2. On the open source side, it supports MySQL, MariaDB, and PostgreSQL, including their cloud-native variants like Amazon RDS and Amazon Aurora. This makes DMS ideal for enterprises modernizing legacy systems or consolidating databases in the cloud. In the NoSQL category, DMS supports MongoDB and Amazon DocumentDB as both source and target, enabling migrations of document-oriented data stores. This is particularly useful for developers moving workloads between self-managed NoSQL environments and AWS managed services. When it comes to analytics destinations, DMS supports Amazon S3 as a target, which is perfect for building out data lakes. DMS can write data in structured formats such as JSON or Avro, enabling downstream analytics with services like AWS Glue, Athena, or Amazon EMR. You can stream data directly into S3 with partitioning support, making it efficient for high-volume ingestion. For data warehouses, AWS DMS supports Amazon Redshift as a target, allowing you to feed structured, cleansed data directly into your analytics environment. This is especially useful for organizations that want to unify operational and analytical data for real-time business insights. With support across these categories, AWS DMS allows you to move, replicate, and modernize your data no matter where it lives, enabling migrations that span OLTP systems, NoSQL stores, and big data architectures alike. When you're migrating databases across platforms, especially from one engine to another, migrating the data is only part of the equation. Just as critical is converting the database schema, the business logic, and the application code that interacts with the database. That's where the AWS Schema Conversion Tool, or SCT, comes into play. SCT helps you assess and execute both homogeneous migrations, like Oracle to Amazon RDS for Oracle, and heterogeneous migrations, both such as SQL Server to Aurora PostgreSQL or Oracle to Amazon Redshift. The first step in this process is generating a detailed assessment report. This report evaluates schema compatibility, highlights potential conversion issues, and provides a roadmap for what can be automated and what requires manual intervention. Once the assessment is complete, SCT performs the actual schema conversion. It converts tables, indexes, views, and even more complex objects like stored procedures and user-defined functions. For data warehouses, it also translates schema structures optimized for columnar storage and analytical queries. SCT also goes a step further by converting embedded application code. This includes SQL statements hard-coded in application layers, which often pose a bottleneck in cross-engine migrations. The built-in code browser allows you to view, review, and edit converted code, with syntax highlighting that pinpoints lines requiring manual updates. SCT supports SSL connections to both source and target databases, ensuring encrypted secure transfers of sensitive metadata and schema definitions. Additionally, SCT integrates seamlessly with AWS Glue to support the modernization of legacy ETL pipelines. Instead of relying on outdated rigid ETL procedures or hand-coded scripts, SCT can help convert these into serverless, scalable AWS Glue jobs. This not only simplifies ongoing maintenance, but also improves scalability, cost efficiency, and long-term manageability of your data transformation workflows. For data warehouse migrations, SCT provides data extractors that pull data from on-premise systems and stage it efficiently in S3 for bulk loading into Amazon Redshift. Once the data is in Redshift, SCT can optimize schemas for performance by aligning distribution keys, sort keys, and data types with Redshift best practices. Overall, the schema conversion tool is an essential companion to DMS, making the transition between platforms smoother, faster, and smarter. When performing a heterogeneous database migration, in this case, moving from SQL Server running on premises to Amazon Aurora with PostgreSQL compatibility, a carefully structured approach ensures minimal disruption and maximum efficiency. Let's walk through this journey in 4 key steps: plan, assess, convert, and migrate. We begin with the planning phase. This is where stakeholders align on goals, define the scope of the migration, and identify the business drivers, whether it's reducing licensing costs, modernizing the tech stack, or scaling applications. During this phase, teams gather metadata about the existing environment, including database size, usage patterns, dependencies, and SLAs. Planning also includes choosing the right AWS targets, such as Amazon Aurora. Next comes assessment and conversion, where the SCT takes center stage. SCT performs a detailed analysis of the source SQL Server schema and generates an assessment report. This report flags which objects are compatible and which need manual adjustments. SCT then proceeds to convert the schema, including tables, views, stored procedures, and functions from SQL Server's T-SQL dialect to PostgreSQL compatible syntax. It also identifies embedded SQL inside applications and helps convert that code too. Once the schema has been converted and deployed on the Aurora target, we move into the migration phase. This is where DMS comes in. DMS connects to the on-prem SQL Server and starts with a full data load. After that, it switches to change data capture mode, continuously replicating changes from the source to the target to ensure that two systems stay in sync. Such a structured approach is the foundation for reliable, scalable, and successful heterogeneous migrations to AWS. In a homogeneous migration, where the source and target databases share the same engine, in this case, PostgreSQL on-premises to Amazon RDS for PostgreSQL, the process is much more straightforward. Since there's no need to convert schema or business logic between engines, we can skip the assessment and conversion phases entirely. The migration is handled entirely by DMS. First, we provision a DMS replication instance and set up source and target endpoints. DMS begins by performing a full load of the existing data from the on-prem database to RDS. Once the initial load is complete, DMS switches to CDC mode, streaming any new inserts, updates, or deletes in near real time. This keeps both systems synchronized until you're ready to cut over. Because the engines are the same, compatibility issues are minimal, downtime is reduced, and the path to production in the cloud is significantly faster. This is the ideal use case for a simple, fast, and reliable cloud migration using DMS. When migrating from large on-premises data warehouses to Amazon Redshift, a lift and shift strategy isn't always efficient, especially when dealing with petabyte-scale data sets. That's where AWS Schema Conversion Tool Extractors, or SCT extractors, become essential. SCT extractors are purpose-built agents designed to handle massive data warehouse migrations from platforms like Teradata, Netezza, Oracle Exadata, and Greenplum. These are analytical systems with complex structures and huge volumes of historical data. Extractors allow you to efficiently move that data to Amazon Redshift, AWS's managed cloud data warehouse. These extractors use an agent-based architecture, which means the extractor is deployed close to the source system, either directly on it or in a local environment with fast access. This setup minimizes network latency and offloads heavy processing from your core data warehouse system, keeping production workloads unaffected. During extraction, data is pulled using parallelized and optimized methods, making the process significantly faster than traditional exports. Once extracted, data is written to Amazon S3 in a compressed and structured format, and ideal for downstream loading into Redshift or staging for transformation with services like AWS Glue. In tandem with data movement, SCT handles the metadata and schema mapping, converting legacy structures into formats optimized for Redshift's columnar storage and distributed architecture. Another key feature is fault tolerance. If a job is interrupted, SCT extractors can resume from the last successful checkpoint, reducing the risk of data loss or duplication. All of this is fully integrated into your SCT project workflow, giving you a single pane of glass to manage both schema conversion and bulk data movement, bringing you one step closer to a modern, cloud-native analytics platform. A critical component in any cloud migration journey is understanding what you're up against, and that's exactly where the database migration assessment comes in and is provided through the SCT. One of the most valuable outputs from SCT is the assessment report, which estimates the complexity of converting your source schema to the target AWS database engine. This report gives you a detailed summary of which objects can be automatically converted, and more importantly, highlights areas that require manual intervention, such as unsupported data types, functions, or proprietary SQL logic. You can view this report directly within the SCT interface or export it to CSV or PDF, making it easy to share across teams or archive for documentation. When working on projects involving multiple source and target databases, SCT is smart enough to aggregate all conversion pairs into a single, unified assessment report, providing a comprehensive view of your entire migration scope. Even if you haven't yet connected to a live target database, SCT allows you to use virtual target platforms. This means you can simulate a migration scenario and get a full assessment of schema compatibility without provisioning any target infrastructure. Ultimately, this assessment process helps you identify effort, prioritize workloads, and reduce risk, setting the stage for a smoother, more predictable migration. When migrating multiple databases to AWS, knowing where to start and how much effort is involved can be a major challenge. The Workload Qualification Framework, or WQF, helps simplify this complexity through automated assessment of your existing database workloads. It's especially valuable for organizations managing large portfolios of databases. Whether you're planning to move 10 databases or hundreds, WQF helps you evaluate each one's suitability for AWS managed services like Amazon RDS or Aurora. It supports both homogeneous and heterogeneous migrations, identifying schema and feature compatibility issues upfront. This means fewer surprises during execution. WQF also produces detailed, actionable reports that help teams understand the scope and complexity of each workload, highlighting what can be migrated easily and what needs refactoring. The sample report provided two target options for the migration: Amazon RDS for MySQL and Amazon RDS for PostgreSQL. This is a high-level summary of the findings that form the starting point to assess the migration effort. The Workload Qualification Framework classifies database workloads into 5 categories based on their complexity and readiness for migration to AWS Managed Services. These classifications help you make informed, data-driven decisions about how to approach each workload. Category 1. These workloads are low-hanging fruit. They contain basic schema elements and SQL constructs that are fully compatible with the target database engine. They can often be migrated with minimal changes and make excellent starting points to build migration momentum. Category 2. These workloads require some refactoring but are still relatively straightforward. There may be a few stored procedures, triggers, or functions that need conversion. These projects typically pose low risk and are ideal for teams getting used to AWS services. Category 3. These workloads contain advanced SQL features, proprietary constructs, or non-standard code that needs significant manual intervention. Migrating them will take more planning, testing, and possibly re-engineering application logic. Category 4. Some workloads use features that aren't supported at all in the target AWS service, such as certain data types, system-specific stored procedures, or unique indexing behaviors. These require either staying on the same engine via lift and shift or re-architecting the solution entirely. Category 5. These are non-database workloads or systems incorrectly identified as database targets. They're excluded from migration planning to keep focus on the real candidates. The Workload Qualification Framework doesn't just assess compatibility. It also quantifies the complexity and effort involved in migrating each workload. This allows teams to prioritize migrations intelligently, focusing first on databases that are cloud-ready and deferring those that require significant engineering effort. By performing this analysis upfront, WQF helps organizations avoid common pitfalls like unexpected code refactoring, overlooked incompatibilities, and poorly scoped projects. The result is a more predictable, efficient migration plan with fewer surprises midstream. When planning a large-scale database migration, one of the biggest challenges is simply knowing what you have and what's feasible in the cloud. That's where AWS DMS Fleet Advisor comes in. It's a free, fully managed capability with an AWS Database Migration Service that helps you take the guesswork out of migration planning. Fleet Advisor automates the discovery and assessment of your entire database fleet, scanning multiple on-premises environments to gather metadata, configuration details, and usage patterns across SQL Server, Oracle, MySQL, PostgreSQL, and more. This is done using lightweight agents with minimal disruption to your existing workloads. Once the data is collected, Fleet Advisor presents you with all the viable options for running these workloads on AWS. Whether you're considering RDS, Aurora, or even Amazon Redshift, the tool helps you explore the most cost-effective and performance-optimized paths. It also helps you build financial models for each option, enabling you to compare TCO, estimate cloud costs, and align architecture choices with your organization's business goals and constraints. By reducing manual effort and providing deep insight, Fleet Advisor empowers teams to make informed, strategic decisions, transforming what used to be a complex, spreadsheet-driven process into a fast, data-backed experience ready for cloud at scale. When using AWS Database Migration Service, understanding the different types of migration modes is essential to choosing the right strategy for your workload. DMS supports 3 primary migration types: full load, change data capture, CDC only, and full load with CDC. Let's start with full load. In this mode, DMS copies all existing data from the source database to the target in one bulk operation. It's best suited for use cases where downtime is acceptable or when the source system can be taken offline temporarily. This approach is simple and fast, but it doesn't replicate any new changes that occur after the migration begins. That makes it ideal for static or archive-style datasets, where the data doesn't change frequently. Next is CDC only, or change data capture. This mode replicates only the changes like inserts, updates, and deletes that happen after a specified start point. It's most useful when the source and target databases are already synchronized, or if you're performing continuous replication for high availability or disaster recovery. CDC relies on the ability of the source database to capture changes using transaction logs, binary logs, or equivalent mechanisms. And finally, we have the most commonly used mode, full load plus CDC. This strategy begins with a full load of existing data, followed by ongoing replication of changes in near real time. It's ideal for production workloads where downtime must be minimized. While the full load runs, DMS starts capturing ongoing changes in parallel. Once the bulk load completes, it applies the captured changes, ensuring that the target stays in sync with the source right up to the cutover moment. Together, these migration types offer flexibility to support a wide range of use cases, from simple batch transfers to complex zero-downtime migrations. When migrating databases to AWS, one of the more specialized considerations is handling large objects, which include data types like clobs, blobs, enclobs, and other forms of unstructured or semi-structured content. These are typically used to store large text data, multimedia content, or XML files, and their size and format make them a unique challenge during data migration. AWS Database Migration Service provides three distinct modes to manage the migration of lobs. The first is full log mode, where every large object is fully migrated, regardless of its size. While this ensures data completeness, it comes at the cost of performance, and throughput can drop significantly due to the overhead of transferring massive binary or text data. To improve speed, there's limited log mode, which allows you to define a lob size limit. Lobs below this threshold are migrated, while anything larger may be truncated. This offers better performance but introduces the risk of partial data, which can be acceptable for certain use cases, like logs or descriptions. The third option is inline lob mode, ideal for small lobs that can be treated like standard column values. It's the fastest method, but not suitable for large or variable-sized data. For more complex workloads, AWS DMS also supports lob chunking in full lob mode. This technique breaks large lobs into smaller, manageable pieces, ensuring they can be migrated reliably without overwhelming the system. A particularly useful feature is auto-switching mode, which starts in limited lob mode for optimal performance, but automatically switches to full lob mode when a row contains a lob exceeding the defined size limit. This provides a smart balance between speed and data integrity. And finally, don't forget the target database's limitations. Not all engines or schemas handle lobs the same way, so be sure to verify compatibility, particularly around size limits and data encoding. Migrating lobs may be tricky, but with the right settings, DMS makes it manageable and efficient. When undertaking a database migration, especially across complex or large environments, consistency and structure are key. That's where migration playbooks come in. These playbooks offer a standardized, prescriptive approach to managing migrations, ensuring that every team follows the same proven best practices, minimizing errors and reducing risk. Migration playbooks provide step-by-step guidance across every phase of the migration lifecycle, from initial discovery and assessment to schema conversion, data replication, cutover, and validation. Each stage is clearly defined with associated tasks, tools, and expected outcomes. This structured approach helps teams stay aligned and on track, even in the most dynamic environments. What makes these playbooks particularly powerful is that they're often technology-specific. Whether you're migrating from Oracle to Aurora, SQL Server to PostgreSQL, or moving your data warehouse to Redshift, there's a tailored path that accounts for the nuances of each source and target system. This reduces surprises and ensures compatibility throughout. Migration playbooks are also tightly integrated with AWS tooling. They include detailed instructions on when and how to use services like DMS, SCT, Fleet Advisor, and SCT extractors, helping you take full advantage of the AWS ecosystem during your migration journey. Beyond technical steps, playbooks include risk mitigation strategies and rollback plans. They define decision gates, pre-cutover validation checks, and procedures for gracefully reverting changes if something doesn't go as planned, critical for minimizing downtime and maintaining business continuity. Finally, they include operational readiness checklists to make sure nothing is missed, from IAM permissions and VPC settings to database parameters and connectivity validation. All of this combined ensures that your migration is not just fast, but reliable, secure, and well-governed. One of the most critical aspects of any database migration is making sure that the data has been transferred accurately. AWS Database Migration Service, or DMS, offers built-in data validation capabilities for relational database migrations to help ensure the integrity of your data on the target. DMS validation works by comparing the data between the source and the target. As records are loaded or changed, DMS incrementally checks that the same data exists and is consistent in the target database. This is especially useful during change data capture or CDC, where new data is continuously replicated. By enabling validation during this phase, you can track correctness in near real time. To use validation, it must be explicitly enabled in the DMS task settings. It's not on by default. Once enabled, DMS begins to track and validate as data is written to the target. An important requirement for validation to function is that each table being validated must have either a primary key or a unique index. These identifiers are necessary to match and compare records between the source and the target. Without them, DMS won't be able to reliably determine if a row has changed or been migrated successfully. DMS also supports partial validation of large objects such as clobs or blobs. While not fully exhaustive, this still provides a level of confidence when dealing with these complex data types. However, it's worth noting that enabling validation comes with a performance cost. It introduces additional overhead, which can increase the total migration time and resource usage. Still, in most production scenarios, this trade-off is worthwhile to ensure trust in the migration. It's also important to clarify that validation is exclusive to DMS. It is not supported by SCT extractors. So, for data integrity verification, DMS is the primary tool in your migration toolkit. When planning a data migration using AWS Database Migration Service, it's important to understand how DMS is priced, so you can estimate costs accurately and optimize your resource usage. DMS follows a pay-as-you-go pricing model, which means you're only charged for the resources you use, no upfront fees or long-term commitments. The main cost component is the replication instance, which performs the actual migration. You can choose from various instance types based on CPU, memory, and network performance needs, ranging from cost-effective T3 medium instances to high-performance R5 series. You're billed per hour based on the instance type and the region it runs in. In addition to instance costs, you may incur storage charges. While DMS includes some built-in storage, any additional space required, such as for cached data during a full load or buffered changes during CDC, will be billed separately. Another key pricing factor is data transfer. If your migration involves cross-region replication or moving data from an on-premises environment into AWS, standard AWS data transfer rates will apply. For smaller workloads, DMS offers a free tier, which includes up to 750 hours per month of usage on a T2 micro instance for up to 6 months. This is ideal for testing or proof of concept migrations and can help you get familiar with the service without incurring charges. It's also worth mentioning that the SCT is available at no additional cost. However, if you use SCT in conjunction with other AWS services, such as uploading converted schema to Amazon S3 or triggering a DMS task, you might incur standard service charges for those resources. Lastly, DMS does not include built-in backup capabilities, so if you require snapshots or long-term storage, you'll need to leverage other AWS services, which are billed separately. Effective monitoring is critical for ensuring that your database migration with AWS Database Migration Service runs smoothly, reliably, and within expected timelines. AWS DMS offers a rich set of monitoring tools and integrations to help you stay in control throughout the migration process. At the core of monitoring is Amazon CloudWatch, which receives a comprehensive set of performance and diagnostic metrics from DMS. These include task-level metrics like latency, throughput, error counts, and replication lag, as well as CPU and memory utilization of replication instances. The AWS DMS console itself provides real-time visibility into the health and status of your replication tasks. It displays progress indicators, error messages, and task states, making it easier to identify bottlenecks or failures as they happen. For more granular insights, DMS offers task logs that detail each stage of replication, including full load, cache changes, and ongoing CDC activity. These logs help troubleshoot issues like schema mismatches, connection errors, or transformation failures. If you need deeper visibility, enhanced logging can be enabled. This option captures more verbose logs that include individual transaction activities and transformation steps, and particularly useful for debugging complex migrations and real-time change data capture. In terms of security and auditability, AWS CloudTrail records all API activity related to DMS. You'll know exactly who made changes, when and from where, and helping you maintain governance and compliance. You can also enable Amazon SNS notifications, which alert you in real time when key events occur, like when a task starts, fails, or exceeds a latency threshold. And with event subscriptions, you can proactively respond to specific task or instance events without constantly watching the console. Finally, DMS metrics are also compatible with third-party monitoring solutions and custom dashboards, allowing you to embed migration visibility into your broader observability framework. Thank you for joining us in this video. If you haven't already, we'd love for you to subscribe to our channel to stay updated with our latest content. We look forward to sharing more insights with you in another video. Until then, keep exploring. And thank you for watching.